Increasing order of reactivity in group 1 is lithium, sodium, potassium, rubidium, cesium. Down the group, reactivity increases. On the other hand, if you look at halogens, it is the reverse. Fluorine is super halogen, very reactive, and Cl, Br and I are successively less and less reactive. We are supposed to explain this. Why? It's very simple. If you look at metals, when we are moving down the group from lithium, sodium, potassium, rubidium, cesium, you discover that on moving down the group, see, metals typically react by losing electrons. So, lithium to cesium, the tendency to lose electrons increases. So, electropositivity increases down the group. Why? Because as you go down the group, ionization energy decreases. It becomes easier to lose electrons, so it becomes easier to react. So that is why reactivity increases down the group in alkali metals. If you look at halogens, the scene is very different, because when you talk about halogens, halogens typically are electronegative, right? If they are electronegative and you find, that means they are not going to release electrons, they would rather accept electrons. So, tendency to accept electrons decreases down the group as the size increases. But then electron affinity has an exception also. Chlorine is more electron, it has greater electron affinity as compared to fluorine. That's okay. But again, a very major tendency in these cases is, of course, electronegativity. Electronegativity decreases also down the group as the size increases. And the most important factor is the bond length. Bond length increases. Therefore, bonds become weaker, with therefore lesser energy is released during bond formation if you are moving down the group. So when it comes to covalent bonds, you find lesser and lesser energy is released if you are moving down the group. That is why reactivity decreases. And if you are talking about ionic compounds, then small anion F minus will give you a higher lattice energy. Higher lattice energy again means higher reactivity. So may it be ionic or may it be covalent, halogens, amongst halogens, fluorine is the most reactive. Why? Because it has highest electronegativity, easy. FF bond can break very easily. It has very low bond dissociation enthalpy. It forms very strong bonds, and it has very high lattice energy as well. So all these things contribute to relatively higher reactivity of F as compared to Cl or Br or I. Right?